And thanks for joining this session today. Following up the previous session delivered by Katia, we are going to see the approach that Red Hat has and is having in the approach to the next frontier of 5G, the disruptive approach that AI has, and how it's influencing the road to 6G. Because indeed, when we analyze the digital transformation in the enterprise space, the focus is almost always captured by consumer-facing applications, rapid deployment of artificial intelligence. This is the requirement that we are receiving as the Red Hat Telco Center of Excellence. But there is an underlying infrastructure layer that binds all these components together, and it's currently undergoing the transformation, the radical transformation in the last few years. This is the network. So today we are going to look in the old definition of the network as a rigid utility or a cost center, and discuss how telecommunication operators are rewiring their infrastructure. We will examine why a cloud-native open horizontal framework is the prerequisite for scaling, and how autonomous operational models tackle this massive distributed complexity, and how you can pave the way for a software-defined based 6G. So let me switch to a quick agenda on for this session, and we are trying to split up the discussion in a progression, starting with the foundation of the technical history of the Gs from 2G to 6G, and how AI updates our operational model. From there, we will transition to the core operating model that Red Hat envisioned, detailing the economical and technical differences between vertical silos and horizontal cloud, with a cohesive partner ecosystem. And then at the end, we will map the timeline to 6G and the next horizon innovations. Then, as Katia had in her presentation, we have some references to some customer success stories and a strategic review. Let's start with the first chapter by looking at the foundational baseline, because since AI and content in general is only as good as the data it can access and process, the nervous system that processes them is the network, scalable, reliable, and with low latency. If we trace the trajectory by generation, this progression is quite clear, because 2G digitized voice, 3G introduced the mobile data, 4G completely unlocked the consumer mobile application economy. But when 5G has been designed and introduced, the goal shifted entirely away from the single consumer and introduced a cloud-native service-based architecture that decoupled the traditional network software functions from proprietary single-purpose outward boxes, and defined the shift to a hybrid cloud model that can be deployed either on public, private 5G, or edge or far edge, and now is able to adapt dynamically, laying the ground for 5G advanced with the introduction of AI/ML integration, and preparing for a hyper-distributed 6G computing fabric. As we prepared for what's next, our focus is currently on building a bridge across successive waves of technology. In the immediate term, 5G Advanced introduced the AI-ready infrastructure with intelligent edge to drive down the operational cost, and our resource and development strategy inside of that incorporates non-terrestrial networks and quantum compute layer. Probably you heard the recent announcement from the Red Hat Summit earlier in May 2026. And preparing for a 6G architecture built from day zero on intent-driven and self-managed design principle. Indeed, when my colleagues from the Telco Center of Excellence sit down with global telecommunication executives, the core requirement is clear. They need to evolve their networks into the backbone of a global AI economy. And to achieve this, it is essential to break down the barriers between legacy silos, isolated clouds, and operational islands. So a shared vision that we received is to provide a common cloud-native, software-defined foundation that enables services across both network and IT environments, keeping an eye on a consistent platform layer with sovereignty in mind, and that either can sit in a central data center, in a public cloud, at the far edge cell site, or but where the deployment, the security, and the management of this infrastructure remain identical. So if we narrow down a little bit on the topics that we just mentioned, we can see that modern organizations want to develop and deploy cloud-native AI-based application in production quickly to improve customer experiences, security, operational efficiencies. Red Hat, in this case, provides application and data science teams with a unified platform to manage the entire AI ops and ML ops lifecycle. This means that you can address complexity with a consistent operational experience and use integrated tools to deploy, manage, and operate the networks and the ET infrastructure. As those networks become highly distributed, we must also address the complexity of scales, and this required a shift towards autonomous intelligent networks. And we are doing that combining open APIs to program machine learning, autonomous decision loops, and build networks that continuously monitor themselves and make real-time adjustments. Red Hat, in this case, has developed an autonomous framework using modular open source approach, and the goal is to move the operational layer towards hyper-automation, removing routine manual inefficiencies, and improving network resiliency to accelerate new service creation. Sorry. Doing that in a omnicomprehensive infrastructure where we can run any application and any workload in on any platform, on one common platform. So we tried to provide a single foundation that hosts virtualized, cloudified run functions, private 5G core function, IT application, and modern AI engines side by side. This allows us to retire proprietary hardware stacks progressively while keeping legacy applications running safely until they have reached their end of life cycle and or have been fully modernized. Last but not least, also keeping in mind that digital sovereignty is a key topic in this case, because in a distributed infrastructure environment, the attack surface, I heard the last question from one of the attendees to the previous session, naturally expands. It makes digital sovereignty and security a non-negotiable priority. And Red Hat, in this case, has delivered a security-focused open source software, has been delivering open source software security focused for over 30 years, and we keep on implementing security throughout every phase of our software supply chain. Now, if we move directly to the second pillar of our conversation, this brings to the core architectural decision that defines the economics of our network, which is the operating model. We are trying to see why legacy vertical integration models are failing and how an open horizontal architecture shifts also the financial equation of the infrastructure itself. Let's examine the architectural evolution. I took this slide from one customer. So indeed, it's based on real observed data, not proposed by Red Hat as a vendor, but proposed from a telco operator to Red Hat. We see on the left the traditional vertical silo, a single vendor solution where different NEPs bundles their software with their own proprietary cloud layer and custom hardware with rigid isolated blocks and bringing to life cycle challenges, manual operation, and a single vendor lock-in. The middle column presents a traditional intermediate step, running vendor products on common cloud technology. And indeed, this brings up to yields roughly to our 30% operational efficiency, but the ultimate destination is on the right, where a true horizontal telco cloud with unified tooling, you decouple the hardware from the software entirely, and multiple vendor applications run on a common shared cloud abstraction plane. In this case, a multi-vendor, multi-tenancy approach delivers an additional 30 to 40% saving in CapEx and OpEx, providing also a single pane of glass for network observability and streamlining an entire automated CI/CD lifecycle through the overall infrastructure. Committing to that horizontal cloud model, we can redefine the operational practices and move away from manual remediation and shift towards intent-based closed-loop systems where AI predicts the failures and before they can degrade service quality. This architecture is highly based on zero-touch operations, because taking a GitOps approach where infrastructure configuration are managed as code in a central repository, we can automate the lifecycle management and allowing operation teams to deploy, patch, and maintain thousands of distributed edge nodes without manual on-site intervention and keeping consistency on that lifecycle. Now, a common and fair question that based on these assumptions, and I also heard in the previous set of questions, is that if we move away from pre-packaged vertical vendor solution, do we inherit the burden of integrating all these open source components ourselves? The answer is no, and this is precisely where that value as a strategic partner resides. Red Hat acts as the integration buffer in this case. We do the heavy engineering lift on pre-testing, validating, certifying the horizontal layer that you can find in the middle against major silicon providers, hardware OEMs, and application software vendors on the top. You inherit, in this case, an open source but completely flexible supply chain, but with the compliance, security, and predictability of an enterprise solution at the same time. To give you an idea of this collaboration, I'm adding and the active engineering work within the major interest bodies. I've added a recap slide because every presentation needs a logo slide where I'm showing some of the groups and community alliances and partners that the Red Hat Telco Center of Excellence is working on. You can find some names like the Orion Alliance for cloudification, orchestration, and security of the infrastructure. The definition of the future 6G architecture principles inside 3GPP, and the engineering involvement with hardware and software partners. Now, let's go to the last section of our road. As technology cycles move rapidly, let's explore the roadmap from 5G to 6G reality. Let's be candid in this case. The global deployment of 5G has been a massive technical achievement, but many operators are finding how I found it complex and difficult to quickly monetize in the consumer market. And we are trying to avoid past mistakes. We must focus in that case on pragmatic, realistic business cases, redefining our operational models before the technology. In this case, we must find the return of investment of 5G now by using AI-driven operational model to cut down the underlying costs and automate the on-demand services that enterprises are actually willing to pay for. To achieve this, our guiding principle for road to 6G is to build an open standards, open ecosystem, AI native, based from day zero. In this case, taking open standards approach is foundational, and we prevent vendor fragmentation in the deployment of our infrastructure. The strategy is also not to treat each improvement in an all-at-once infrastructure redeployment, but centering on incrementally deploying advanced features into already present high-value verticals that we prepared from the grounds. In this case, our goal is to prepare a substrate for a fully native AI ecosystem to ensure that we can deploy and develop and manage any type of workload or AI model at scale, securely and reliably across any hybrid environment. Again, to reiterate that in a software-defined horizontal architecture, the transition to 6G is executed as a series of rolling software updates running on standards off-the-shelf compute hardware. And Red Hat, in this case, provides a consistent operational model that natively supports advanced orchestration, AI agents, and a diverse hardware accelerator. This allows the organization to focus on service innovation while inheriting an automated, secure platform layer that scales as technology evolves. Now, architectural strategies and technical roadmaps that we discussed so far require real-world validation. Let's move into our final segment and look at some customer success stories that I took from the recent Red Hat Summit announcements. So they are public, and you can find more details on each of them from the Red Hat Summit contents. I will provide you the links later. Let's start with Telefónica Brazil, who migrated to OpenShift the virtual machine and cloud-native applications. They removed infrastructure silos and they achieved the metrics that I am showing here. The IT infrastructure scaling time dropped from 24 hours to 10 minutes. And they were able also to reduce CPU and memory consumption, and also slashing the patch update to window by 91%. This proved that horizontal cloud modernization drives a massive backend efficiency and improves customer interactions. The second one I'm presenting now is Vodafone Oman, who is executing a full Telco transformation with a target of being 100% cloud native by 2028, standardizing on Red Hat platforms, and creating a common layer that simplifies the day-to-day management. Again, using OpenShift virtualization now, they run a container application and legacy virtual machines on a single platform, and they eliminated the overhead of separate infrastructure silos, and they are ready also to host AI workloads on the same operational model. The last one is a customer that indeed already progressed on that AI scenario, where Telenor is already building Telenor AI Factory to bring scale, sovereignty, and control to production AI. And they use, again, Red Hat has the common cloud layer to ensure that kind of flexibility, portability, and zero vendor lock-in. So again, in this case, as I was anticipating in the previous ones, they are running traditional workloads and advanced AI models side by side, avoid costly operational silos. Moreover, they can run any AI model on any accelerator across any cloud, leveraging also Red Hat confirmed sovereign support within the EU to maintain the operational sovereignty over critical operations. So I think that we are almost over in our session today. So let's try and summarize what we discussed so far, and we get to summarize what we were talking about. I think that we can conclude that it comes down to a two-way equation you can find in this recap, which is network for AI, which means building a consistent horizontal platform across network, IT, and edge domains to deliver a sustainable economics for our data strategy. On the flip side, AI for networks means that we can turn AI ops into a reality using automation and intelligent edge platforms to deploy autonomous networks and deliver profitable B2B services at scale. This brings the narrative that we covered today to a close. I anticipated you that most of the use cases that I presented to you have been presented more extensively during the last Red Hat Summit. So I think that if you want to dive deeper into the topic, you can watch the technical keynotes from Red Hat Summit happened in May, and review the book of news from the Red Hat Summit, and explore the resources available on Red Hat TV and the Summit portal. Then at the end, finally, if you want to, as I probably would do, have a technical and hands-on grip on the things that we just discussed, you can better understand its technology and see it in action in the interactive demo experience provided during the summit, where you can get hands-on with the solution that I just described, test the automation pipelines, and see how the horizontal cloud substrate operates. I think that we are done, Annie. So
okay,
thank
Federico.
you all
Sorry,
very
I
much.
jumped in a bit quickly because you said, and finally.
Yeah, indeed. It was the last
sorry
one.
about that. I've just got one. I don't know if it's a question really or an observation, and It's just that I think what you described as the rocky 5G road, and how we want to move to a profitable 6G future. I mean, it seems to me that one of the really big issues with 5G was moving the core to being cloud, the core network to being cloud-based, which is not just about a different technology, but a completely different approach, a different topology, a different way of working. I mean, it's just a complete, it's a mind shift and all that stuff. And I'm just wondering if you think that we're facing a similar huge change with moving from, thinking about a cloud-based core to embedding intelligence in the network, sort of at scale. I mean, do you think again it's a similar kind of big step, or do you think it's not as daunting?
I think that, well, at least from what I'm seeing from the current proposition from Red Hat and other, and what the vendors are approaching, the horizontal approach helps us to avoid to repeat that
Yeah.
in the future. So preparing the way for an horizontal cloud approach, where you are using the same operational model. I don't mean that you are deploying a single cluster spanning all the private and public cloud, but of course, using the same operational model on different infrastructures. You mentioned the cloud, the public cloud, but I'm thinking about the edge or the far edge as well, while keeping the data center, the on-premise data center operational as it is now. Allows us to concentrate then on the application layer and the AI layer that we can deploy on top of that framework.
Okay, Federica, I look forward to speaking to you and having you back in future to talk about, as you framed it, AI ops to autonomous intelligent networks. I look forward to seeing how we do. Thank you very much
Yeah,
indeed.
indeed.
That was a really interesting presentation.
No, thanks to you, Annie, and thanks to all the audience for this session today.